There, folks, we're now in our video in algebraic fractions, wherein we're going to present lots of exercises for all the topics that we've talked about, we have discussed. So in this video, I will be presenting to you 5 examples on how to solve algebraic fractions from the easiest one going to the most difficult. So let's try. Number one, if you want, you can pause the video to try this on your own, and then we're going to answer this after that. Okay, so that's it. Kindly ready your answer, and then we're going to answer this right now here. So notice that in number one, we have similar fractions since they have the same denominators. So you don't need to do something with the denominators. We just need to copy it. Okay, so we just need to copy the denominator, which is 3. So we're going to put the numerator here of the first term as x minus 4. Copy the operation plus we have 2x minus 1. Simplifying that here, maybe we can fix this. Oops. Okay, simplifying the numerator. Okay, simplifying the numerator here will give us what? What will be our final answer? Okay, so x plus 2x, these are the like terms. X plus 2x is going to give us 3x. Okay, and then negative 4 minus 1, they're like terms. They have the same signs. So we're going to add them and then copy the sign. So negative 4 minus 1 is going to give us minus 5. So recall the rules in adding and subtracting integers. We will surely use them still even to this lesson. Okay, so 3x minus 5 all over 3. And that will be our answer for number 1. Okay, that's our answer for number 1. 3x minus 5 all over 3. I hope you got the same answer also. Okay, moving on to our number 2. Here's our number 2 here. Okay, so we have y minus 3 over 4 minus 2y plus 7 all over 8 plus 5y over 12. So let's try to answer this, shall we? First up, it's very clear to see that they are dissimilar fractions since they don't have the same denominators, obviously. So we have here 4, 8, and 12. So what we need to do is to find the LCD, the least common denominator. So that's our first step to do. And then adjust the values of the numerator. So to find the LCD, we need to get the prime factorization of 4, 8, and 12. If you can remember the process, right? 4, 8, and 12. So let's prime factorize. 4 is 2 times 2, 2 times 2. 8 is 3 of them, 2 times 2 times 2. All right, that's 2 cubed for the 8. And 12 is actually 4 times 3. So 4 can be further, um, factorized into 2 times 2. So we have 2 times 2 times 3. Let's put the 3 over here. Okay, and then we're going to get the least common denominator here. We will need to highlight first the common for all of them. So we have a common 2 for all the integers 4, 8, and 12. So let's get that as 1. And also we have another common 2. So we have 2 common 2's, shall we, in both the integers. So 2 common 2's. Okay, so we're only going to count this 2's first once in the multiplication in getting the LCD. So the LCD, least common denominator, okay, is equal to, we have 1 here, 2 times 2, oops, times this one, this 2 here outside, times 3. Okay, so what is this? We have 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is going to give us 24. So 24 is our LCD, the LCD that we're looking for. So meaning all these terms here must have a denominator of 24, and we will be the ones to convert that into 24. So let's do that one by one. Um, okay, so we have 24 divided by 4. It's going to give us what? 24 divided by 4. What's the answer? So obviously it's going to give us 6. Okay, 6, multiply this to the numerator. What we have is, if we can, let's put it together already. So 6, imagine a 6 here, okay, to make this 24. Okay, so 6 times y is going to give us 6y. 6 times minus 3 is going to give us minus 18, okay, all over 24. Okay, and then here, 24 divided by 8 is going to give us 3. So we have a 3 here. Multiply the 3 to all of them. Maybe we can use the minus 3 instead of just 3. So this will become now 24. So what do we have? Maybe we can put it in a single fraction now. So 3 times 2y is going to give us, so minus 3 times 2y is going to give us 6y. Minus 3 times positive 7 is going to give us minus 21. Okay, minus 21. Next, we have 12. 12 divided by 24, rather 24 divided by 12, rather, is going to give us 2. 2. So this becomes 24. We will need to multiply 2 here to the 5. So 2 times 5 is going to give us plus 10y. 2 times 5y, rather, 10y. So this is going to be all over 24. All over 24. Okay, so let's combine the things that we are going to have here. So we have 6y and 6y. Since we have 6y minus 6y, this is going to be canceled since it's going to become 0. And we have 10y which is left. So therefore, after this, what we have is 10y for the term which has a y on it, y with it. So we have 18 minus 18 minus 21. So negative 18 minus 21. So it's going to give us what? 39. So since they're both negative, so we're going to put the negative sign, negative 39, and then all over 24. And yep, that's our answer for the number 2 exercise. I hope you got the same answer also. That's our answer. So 10y minus 39 all over 24. Okay, let's proceed to our third example. Third example looks like this, and obviously we're going to need some factorization. Okay, this is multiplication now. Multiplication of fractions. Let me erase that thing there. Okay, it's a multiplication of fractions. So we can see something in all of them. I think that they are quadratic trinomials. Okay, so they're quadratic trinomials wherein we can factor them out, and maybe we can cancel some things before we can even multiply. Because actually from this part we can multiply numerator to numerator, denominator to denominator, but that will be nasty to look at. It will not give us a very good answer in the end, and seldom when we do that we'll need to factorize still to get our simplified form. So why not factorize in this part first? So let's think of a squared minus ab minus 20b squared. So we can imagine something like we have an a here, we have a b here, and we have an a here, and we have a b. So what two integers is that we're going to multiply them? It's going to give us negative 20. So since it's negative, we have something in our minds that the two integers have different signs since it's negative. And then our middle term, our coefficient of the middle term is negative 1. So adding them or subtracting them will give us negative 1. So what are the two integers? Any ideas? Anyways, maybe you can pause the video to answer this whole operation. Yes, you can do that right now. Okay. So after some time, you will think that there are only two integers which is capable of doing that. That is negative 5 and positive 4. So let's put negative 5 over here, and let's put positive 4 here. Why is the 4 positive? Because negative 5 minus 4 is going to give us negative 1. Negative 5 times positive 4 is going to give us negative 20, which is perfect and what we're looking for. In the denominator, let's write first the things that we are to do. And then what two numbers, wherein if we're going to multiply them, it's going to give us negative 12. And if we're going to combine them, it's going to give us a negative 1. Or add and subtract them, it's going to give us negative 1. Okay, any thoughts there? Yeah, I think you got it. Hopefully we're thinking of the same thing. So what numbers will be that? So since the middle term is negative, therefore the one with the bigger absolute value must be the one which is negative. So I am thinking of negative 4 and positive 3. Okay, negative 4 times positive 3 is going to give us negative 12 precisely. And negative 4 plus 3 is going to give us negative 1. So that is the factorization in our number 3. How about on the next term? So let's try to think about it here. So just like in our previous term, so we can put the prerequisites A, B, and then A, B, okay? And then think of a number wherein if we're going to multiply them, it's going to give us minus 6. If we're going to combine them, it's going to give us plus 1. So since they are the product is negative, so we're expecting something where the two integers doesn't have same signs, and since the middle term's coefficient is positive, we're expecting that a higher absolute value will be the one which has the positive sign. So what will that be? Maybe you can think of it. And after some thinking, you will see that the two numbers are positive 3 and negative 2. Okay? Positive 3 times negative 2 is going to give us negative 6. 3 minus 2 is going to give us positive 1. Let's go to the denominator this time. A, B, let's put the things that we are unnegotiably to put. Okay? Now, what are the two numbers? Multiplied together will give us negative 12, and added or subtracted together will give us plus 1. So it's just similar to our denominator here, only that the middle term is positive this time, not negative. So if that's the case, maybe we can just shift the operations here. Instead of 4b minus, or instead of minus 4, let's put it plus 4. And instead of plus 3, let's put it minus 3. Okay? And plus 4 minus 3 is going to give us minus 12. Plus 4 minus 3 is going to give us positive 1. So which is correct. Now, after this time, maybe we can imagine them right now as something under one fraction bar. Under one fraction bar. So if we're going to think of it in that um in that uh in a while in that picture. Okay, so a picture like this, wherein all of them are all under one fraction bar. So we can do cancellation. Sorry, we can do cancellation from these terms to these terms. So if we'll do that, what are the things that we can cancel? Maybe we can think of that for a moment. What will that be? Anything at all? Okay, so first we can see that we can cancel a plus 3b and a plus 3b over here. Okay, so that's good. Next, we can see that we can cancel a plus 4b and a plus 4b over here. And yeah, those are the things that we can cancel. The other things we cannot, so therefore we will just try to move on from that and try to fix that. Okay, so meaning after the cancellation has been made, we are left with these. A minus 5b, a minus 5b times the quantity of a minus 2b, all over a minus 4b times the quantity of a minus 3b. Oops. Okay, so that will be our last last factorized answer, if that's okay with you. But if you want to have the answer which in we're in, we're going to make it a trinomial. Actually, this answer is good already. Okay, I mean we can box this now. But we can also put it like this. Okay, so it can be written as something like, so we're going to use the FOIL method. A times a is a squared. Oops. A times minus 2b is going to give us minus 2ab. um, Negative 5b times a is going to give us minus 5ab. So negative 2ab minus 5ab is going to give us minus 7ab. And then um, negative 5b times negative 2b is going to give us positive 10b squared. 10b squared. Okay? In the denominator, how about this? A times a is a squared. Okay. A times minus 3b is minus 3ab. 4 times a is going to give us minus 4ab. So negative 3ab minus negative or minus 4ab is going to give us minus 7ab. Minus 7ab still. And then minus 4b times minus 3b is going to give us positive 12b squared. Positive 12b squared. B squared. And then either of this will be our answer for number 3 actually. Um, if you prefer a factorized form, it's okay for the first expression to be your answer. If you want it to be in a single expression, so you can put it, or rather in a you know unfactorized one, wherein you're going to expound it via FOIL method. So either of this will do. Okay, either of this will do. Depends on the directions and the and the instructions of the test on what to do. Okay, so that's it for number 3. That's it for number 3. Now let's proceed to number 4 this time. That's number 5. We're going to talk about it after number 4. Number 4 is over here. Okay. Okay, so we're now on the division of algebraic fractions. Division. And recall the rules in division that we need to, get the reciprocal of the divisor and then proceed to multiplication. So it's just like that. It's just like that. And we'll do that right now. Okay. So for number 4, we will just write it here. Or maybe to save some space, we can factorize already this part. So we have x and y, x and y. Okay, what numbers, what integers is that? If that we're going to multiply them, it's going to give us minus 6. If we're going to combine them, it's going to give us minus 1. So maybe it was the same or similar to our previous example. So we can write minus 3 and positive 2. Okay, so minus 3 times 2 is going to give us minus 6. Minus 3 plus 2 is going to give us minus 1. In the denominator, we can see a common factor, which is y. We can get that y out. So it will look like y times x plus y. Okay, y times x plus y. And then let's flip the operation, keep flip change, and then we'll have it here. And as we flip, this will be our new numerator. This will be our numerator, and this will be our denominator. Now, before we write it down, maybe we can simplify it already. X squared plus x, we have a common factor, which is x. So we can take that out. So we have x times the quantity of x plus y. And then we can see in the our denominator, we can apply the difference of two squares here. Since this is a perfect square, this is a perfect square, and they are being subtracted. Um, they're being subtracted. There's a minus sign between them, so we can apply the difference of two squares. So what will it be? Do we have x and 2y, and we have also x and 2y here. Okay, and then we're just going to put a plus and minus sign between the two here, plus minus. Okay, and similarly in our multiplication, to save up some space, maybe we can delete already the multiplication sign here, and then proceed already and put them under one fraction bar. So if we do that, it's going to look like this. Oops. Sorry. Yeah, connecting the dots. Connecting. Okay. Okay, let's imagine it's going to be that perfect. Um, so what can we cancel? Okay, any thoughts? What can we cancel? Okay, so from here we can see that we can cancel x plus 2y and x plus 2y here, and we can cancel x plus y and x plus y here. And we are left with this. Okay, we're left with this equals x minus 3y, x minus 3y times x all over y times x minus 2y. Okay, actually you can write, maybe we can rewrite the x in the in front. That's okay, by commutative property. Okay, let's put it there and delete the x here to make it proper. Yeah. Okay, so that can be our answer. Again, we can expound it if you want. So, but that can be the answer already, or it can be, if you want, we can write it as distribute the x to both of these terms. So we're going to distribute it here and here. So what we have is what can be our answer also, x squared minus 3xy. Okay, and then in the denominator we can distribute the y here and here. So we have xy minus 2y squared. Okay, so either of them can be our answer. Again, it depends on the directions of the test. Um, if 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 it is said that it should be in the factored form, so this will be our answer. If it says to have or to expound it, so this will be the answer. Either way, they are equal. Okay, so either of them is correct. Okay, and then here we go with our last item. This is the one which is most challenging, and we're going to have the okay complex fractions. Okay, complex fractions this time, which will be okay. Be with me here. Okay, so we have our main numerator. This is our main numerator over here. This is our main numerator, and we have our main denominator. So, in order to make things, in order to make things, um, organized, let's fix our numerators first and fix our denominators. After fixing them, we will input them again as one fraction, and then yeah, we will simplify from there. Okay, so let's fix the numerator first. I will put n here as numerator. Let's fix it first. So imagine our numerator, and we're going to get it out from this main fraction, then put it here, and then we'll work from that. X plus y all over x minus y. Oops. Minus x minus y all over x plus y. Okay, common misconception, we can cancel this and this. Okay, that is very, very wrong. Okay, so we cannot do that unless we are doing multiplication. So since there is a minus sign between them, we cannot simply do that. Okay, that's a very common misconception in cancellation of division of fractions. So we cannot do that. We need to find, since our operation is negative or subtraction, so we need to find the LCD and perform the operation. So what is the LCD? If we can, let's move it down first. Let's fix that denominator later. Let's go back to that later. We'll be focusing on the numerator first. And okay, oops, some disturbance from the previous example. Let's kind of erase that. Okay, bye. Okay, and yeah. Okay, let's move on and then let's find the LCD. So as we can see, our denominators are dissimilar. They don't have the same thing, even though they have the x and y, but the operation is not the same. So meaning they are still both different, okay, unique binomials. Because imagine a number x and y. example, 1 minus 2 is different from 1 plus 2. So they're different binomials. So we need to find their LCD. So their LCD actually is just x minus y, x plus y, because um, again, imagine them as 1 minus 2 and 1 plus 2. So they're both different integers. So our LCD actually is just, oops, it's just the operation. I think I cannot fit it there. Let's put it here. Their LCD is just x minus y times x plus y. So if that's the case, we're going to follow through. Please be with me in this part. We would need to follow through this and apply it here in both terms. So x minus y, x plus y divided by x minus y will be, we can cancel the x minus y. Imagine x minus y times x plus y divided by x minus y. We can just cancel the x minus y. Imagine that, please. So if we'll do that, we will cancel this up. And then what will be the one we'll be ending up with? X plus y times the numerator. Again, x plus y times the numerator. So that will give us in the first part of the numerator as x plus y squared. Maybe we can put it there. Or if you want x plus y plus x plus y times x plus y. But to save up space, let's put it square. Right? So x plus y plus times x plus y. Again, x plus y times x plus y is x plus y squared. Now minus, again, we're going to apply this in this term. So x minus y times x plus y divided by x plus y. So it's understood that we can cancel the x plus y. Whatever is left here times it, multiply to the numerator. So we have x minus y times x minus y. Similarly, we have x minus y squared. Okay, x minus y squared. Okay, so that's our numerator. That's as far as what we can do with our numerator. So we'll stop there. We cannot simplify anything just yet. But for now, let's proceed to our denominator. Okay, let's proceed to our denominator. So in our denominator, recall that it looks like this: 1 plus x minus y all over x plus y. Okay, so we need to find also the LCD from here. Um, Imagine a 1 here. So therefore, our LCD is just x plus y. So all of them must have x plus y with them. Let's put them in a single fraction now. So our LCD is x plus y. Let's do that here first. X plus y divided by 1 is still x plus y times 1. We just need to install 1 x plus y here. And then we'll proceed to the next term, plus. So this is x plus y divided by x plus y. Again, x plus y divided by x plus y is just 1. 1 times x minus y is just the number itself, x minus y, since that is the um, identity property of multiplication. So we have this. And notice from this part that we have x plus y plus x minus y. So clearly we can see that we can somehow cancel up the y's. That's going to give us 0. The y's is going to give us 0, and we can combine the x's to make it 2x. To make it 2x. So if we're going to follow that through, okay, if we're going to really simplify that, our d will be in the form of 2x all over x plus y. So that's our denominator. That's our denominator. Now, putting the numerator and the denominator, they're both now simple fractions. Putting them, okay, this is again our numerator, uh, and this is our denominator. Putting them in a single fraction, what do we have? What do we have? Let's write it. Let's write it down. Hopefully, we can have some space still. So, okay, let's have a border here. Okay, telling us that this is okay. Numerator. What's our numerator again? What's our numerator? Okay, x plus y quantity squared minus x minus y quantity squared. So let's write it down. So the numerator of our numerator is, okay, x plus y. I'll try to fit it x plus y quantity squared minus x minus y quantity squared. That is all over, let us write it, x minus y, x plus y. If you want, we can fix it, put the x plus y first by commutativity, x plus y times x minus y. Doesn't matter. By commutative property multiplication, they're just equal. Just want to put the plus sign first. Seems proper. And then our denominator will be 2x here, all over x plus y. Okay. Now, since we have made our numerator and denominator as simple fractions, let's proceed to division right now. And by division, I mean we get the reciprocal of this divisor and then carry on with the numerator. So if we do that, what will we have? Maybe we can fit it here. Oops. Yeah, let's try our best to fit it. As though we, let's try to fit it. Okay, I'm going to save some space here. Okay. Um, so we're going to write it as, in a moment. So x plus y quantity squared, x plus y quantity squared minus x minus y quantity squared all over x plus y times x minus y. Let's proceed now to multiplication. We're going to just put here a multiplication, erase dot, and then proceed with the reciprocal of this denominator of ours. So we have x plus y, oops, x plus y all over 2x. Okay, so from here we can see that from here we can see that we can cancel up some things before proceeding. We can cancel the x plus y here, and then we have the x plus y over here. Okay, and then what do we have? Let's try to simplify that. We have x plus y quantity squared minus x minus y quantity squared. Okay, and then all over 2x times x plus y. So try to fit it here. Actually, I have no more space in this part, but okay, let's try to fit it. Okay, equals, let's put it as the last part. So we have x plus y quantity squared minus x minus y quantity squared all over 2x times x minus y. Okay, and for the for the for the issue of space in my sketchboard, maybe I will leave you to simplify this further if we can simplify this. Okay, if there are some errors, so kindly put down in the comments below what is your final answer, and then yeah, I'll try to, if there are some errors here, so I'll try to make another video for that. But for now, just give me your answers in the comment sections below, and then we'll see what is the final simplified, more simplified form. Since I don't have any space now to give you, okay, there's no more. There's a gray area here which I cannot work on anymore. Okay, so yeah. Okay, so that's it for this video. We have presented 5 exercises for algebraic fractions. First is the similar fractions. Second is the similar fractions. Then we proceeded to multiplication and the division, and then the simplification of the complex fractions. So that's it. Thank you very much for watching. Don't forget to hit like and subscribe. Okay, thank you very much.